Miles-Mathis charge field. Summary. Miles-Mathis, a self-proclaimed physicist, argues that a charge field, consisting of real photons with mass and spin, is responsible for various phenomena, including galactic structure, the Earth's magnetic field, and even the flight of spiders. He posits that this field, which is unified with gravity, drives charge recycling through celestial bodies and even smaller entities like atoms. He refutes mainstream explanations based on dark matter, quasi-particles, and the cosmological principle, arguing they rely on faulty assumptions and incomplete models. He points to several observations, such as comet activity at great distances, the Earth's magnetic reversals, and the Wilkes Land gravitational anomaly, as evidence for his charge field theory. His work is met with resistance from the scientific community, which he attributes to their resistance to accepting a paradigm shift. From the source material which I have uploaded to you, please list 30 takeaway key points with a brief explanation supporting each of the key point. Here are 30 key takeaways from the provided excerpts by Miles-Mathis. Key takeaways from Miles-Mathis excerpts. Dwarf galaxies are herded into rings by larger galaxies, a phenomenon that cannot be explained by the standard model of cosmology, lambda CDM. The standard model predicts the opposite, and astrophysicists often attribute these rings to dark matter, which has no known mechanism for this effect. Point 1. The standard model of cosmology is fundamentally flawed, relying on placeholders like dark matter and the cosmological constant to explain observations. These concepts lack a mechanical explanation and are used to fill gaps in the equations. Point 2. Charge channeling from pole to equator is responsible for rings around celestial bodies, including dwarf galaxies around larger galaxies. Spinning spherical bodies generate angular momentum, creating potentials in the external field that draw in smaller particles, like photons, at the poles and release them at the equator. This charge recycling process forms rings. Point 3. Dwarf galaxies could be found anywhere along the charge channeling circuits of larger galaxies, not just in equatorial rings. Mathis's diagram of charge channeling, originally used to explain Earth's magnetic field, applies to all celestial bodies, including galaxies. Dwarf galaxies could be located along any of the field lines in this diagram, including those perpendicular to the galactic equator. Point 45. Dark matter is not a mysterious substance but simply charge. The equation for the fundamental charge demonstrates that 95% of the universe's mass is photonic, which aligns with the estimated proportion of dark matter. Point 6. Charge is fundamental, contrary to the claims of mainstream physics. Mathis argues that attempts to explain charge using concepts like hypercharge, isospin, and quarks are just mathematical abstractions with no real-world evidence or mechanical explanation. He criticizes PBS spacetime for promoting these theories. 78911011. The weak force is not a fundamental force but a rebranding of electromagnetic interactions to explain charge, a concept Mathis has already explained with his charge field theory. He argues that the idea that the weak force can transform particles by acting on left-handed particles is confusing and nonsensical, relying on undefined terms like weak isospin. 1213. High-energy particles detected exiting the South Pole are not new, exotic particles but simply highly energetic photons. Mathis proposes that these photons, part of what he calls through charge, enter the Earth's magnetic axis at the North Pole and pass straight through, gaining energy from collisions with antiphotons moving in the opposite direction. 14151617. The Earth's magnetic field is generated by charge recycling from the Sun, not by a spinning iron core. The Earth acts as a charge engine, pulling in charge at the poles and releasing it at the equator. The magnetic field arises from the interaction of photons and antiphotons moving in opposite directions along the Earth's axis. 18. The standard model's concept of a zero-radius photon is illogical and needs to be replaced with the understanding that photons have a real radius. The size of a photon increases with its energy due to stacked spins, explaining the larger cross-section of high-energy cosmic rays. 1519. The fractional quantum Hall effect, FQHE, can be explained by the charge field emitted by the nucleus and its interaction with the applied or ambient field. Mathis argues that the fractions in the FQHE are dependent on the material being studied and arise from the interplay of incoming and outgoing charge fields. 202122. The constant h in the Hall resistance equation, R equals h/E2v, represents the real charge photon, and the variable v represents a real frequency related to the charge field. Mathis disagrees with the standard model's interpretation of these variables and argues for a more mechanical explanation based on charge channeling. 2324. The concept of composite fermions used to explain the FQHE is a fictional construct designed to avoid acknowledging the charge field. Mathis criticizes this concept as a fudged electron with no experimental evidence, created to generate degrees of freedom that are not present in the real fields involved. 25. The different topologies observed in the FQHE when studying different materials like arsenic and bismuth can be explained by the unique charge channeling properties of each element. Mathis's nuclear diagrams can be used to predict and explain these variations in charge flow and resulting patterns. 2126. The fraction of 1/2 often observed in the FQHE could be explained by the balance between charge moving pole to pole and pole to equator, or by the 2:1 ratio of photons to antiphotons in the ambient field. Mathis proposes that these ratios create specific field densities and interactions that contribute to the observed fractions. 2728. Gravity and charge, E/m, are separate but unified fields. Although charge pressure exists, it cannot replace gravity because, 1. Gravity is too strong to be accounted for by charge pressure, and 2. The main vector of the charge field at the Earth's surface is upwards, opposing gravity. 293031. Gravity does not have a spin component, unlike charge and E/m. If gravity were a function of charge, it would exhibit a spin component, which is not observed. This supports the idea that gravity and charge are distinct fields. 32. Mystical symbols like the flower of life and the hexagram are likely representations of the atomic nucleus and its charge recycling patterns. Mathis's nuclear diagrams, developed independently, coincidentally resemble these ancient symbols, suggesting a connection between mystical knowledge and the structure of matter. 33343536. The structure of the atomic nucleus is determined by its recycling of charge, a process in which photons are channeled through the nucleus in specific patterns. This charge channeling explains nuclear stability and eliminates the need for the strong force. 39. The 7:5 ratio of the axis to the carousel level in the atomic nucleus, as depicted in Mathis's diagrams, explains the asymmetry observed in certain molecules and ions. This ratio, confirmed by experiments, deviates from the perfect spherical representation in mystical diagrams. 4041. The Earth's charge field is imbalanced, with twice as many photons as antiphotons, resulting in a residual spin that creates magnetism. This imbalance also affects the symmetry of charge recycling patterns and the representation of the nucleus in mystical diagrams. 4142. The Magnus effect, which causes spinning objects to move sideways in a fluid, is analogous to lift on a wing, suggesting that lift is also influenced by a spinning charge field. This supports Mathis's theory that lift is caused by rising charge photons interacting with the wing. 4344. Negative thermal expansion, the phenomenon of some materials shrinking when heated, is caused by increased charge channeling through the material's nuclei. As heat increases, the added charge strengthens the pole-to-pole charge channels, aligning the nuclei and allowing for tighter molecular packing. 454647. The increased conductivity observed in materials exhibiting negative thermal expansion is due to enhanced charge flow through aligned nuclei. This supports the idea that charge channeling, rather than electron behavior, is responsible for both thermal expansion and conductivity. 46. Negative thermal expansion is not observed at the atomic level because the nucleus is already in its most efficient configuration due to the extreme heat experienced during its formation. The heat we can apply in experiments is insufficient to alter the nuclear structure. 48. The 119-degree bond angle in Cu2O is explained by the necessity of using inner holes in the copper nucleus to bond adjacent copper oxide trimers, a configuration that forces charge to flow at specific angles. This highlights the importance of nuclear architecture in determining molecular structure. 495051. The slowing of light in semiconductors is not due to light traveling below the speed of light, c, but rather to light having to navigate mazes and loops created by the specific molecular structure of the semiconductor. This concept is supported by the complex bonding configuration of Cu2O, which can create such pathways for light. 5253. Comet activity at record distances, as observed in C/2017 K2, pan-stars, can be explained by charge friction. The comet releases charge into an opposing field, causing photons and antiphotons to spin each other up, generating heat and driving sublimation, even at low temperatures. 545556. The unusual properties of Uranus, including its axial tilt, cold interior, and hot thermosphere, can be explained by charge recycling and its interaction with the charge fields of neighboring planets. Uranus's perpendicular orientation to the main solar field disrupts its ability to recycle charge efficiently, affecting its temperature and rotation. 575859. Earth's pole reversals are not caused by fluid dynamics in the Earth's core but by changes in the dominant charge field of the galaxy. As the solar system moves through different regions of the galaxy, it encounters areas dominated by either photons or antiphotons, causing the Earth's magnetic field to flip. 60616263. The apparent flips in the Sun's magnetic field every 9 to 12 years are not true pole reversals but rather reversals in the charge returning from the outer planets. These reversals are caused by the changing positions of the planets relative to the Sun and the background galactic field. 6465. The increase in the Sun's magnetism during its short period flips is caused by the spin-up of photons colliding head-on when planets like Jupiter and Saturn are on opposite sides of the Sun. This phenomenon, analogous to the through charge mechanism responsible for iron's magnetism, demonstrates the role of charge interactions in generating magnetic fields. 6667. The high efficiency of photosynthesis can be explained by charge channels in the nucleus creating energy funnels that efficiently transfer energy between molecules. Mathis criticizes the use of quasi-particles like excitons to explain photosynthesis, arguing for a more mechanical approach based on charge channeling. 68697077172. Claims that quantum effects are necessary to explain photosynthesis are unfounded and based on flawed models that ignore the role of the nucleus and charge channeling. Mathis argues that his classical, mechanical explanation provides a more accurate and parsimonious account of energy transfer in photosynthesis. 707377475. The discovery of large-scale, arc-shaped structures in space, like the one observed by a team in Lancashire, provides further evidence for the charge field. These structures are likely formed by galaxies interacting and exchanging charge, analogous to atoms forming molecules through charge bonds. 8081. The upward motion of sound in the Earth's atmosphere is caused by the rising charge field, not by phonons or any other hypothetical mechanism. This observation supports Mathis's theory of a ubiquitous charge field driving various phenomena, including buoyancy and lift. 828384. The ability of spiders to balloon or fly using silk is another manifestation of the charge field. The spider's silk acts as a sail, capturing rising charge photons and ions, which lift the spider into the air. 8586. The Wilkes Land anomaly, a gravitational anomaly over Antarctica, is not caused by an impact crater or a buried object but by a strong charge vortex entering the Earth's south pole. The vortex, composed of photons, pushes on satellites, creating the observed gravity anomaly. 87888899091. The wandering of the south magnetic pole is caused by the wandering of the charge vortex, which is influenced by the varying positions of the Sun, outer planets, and the galactic core. The charge field from these celestial bodies affects the direction and strength of the charge vortex, leading to the observed magnetic variations. 9293. These key takeaways highlight Mathis's central arguments, that charge is a fundamental force driving a wide range of phenomena, that the standard model of physics is flawed and incomplete, and that his charge field theory provides a more accurate and comprehensive explanation of the universe. Copy_all. Thumb_up. Thumb_down. Keep _pin saved to note. How does Miles Mathis explain the magnetic reversals of Earth's poles? Miles Mathis theory of magnetic reversals. According to Miles Mathis, magnetic reversals are caused by the solar system's movement through patches of varying charge in the galaxy. Mathis rejects conventional explanations involving fluid dynamics in Earth's molten core. 12. Here are the key points of Mathis theory. Charge is fundamental. Mathis emphasizes that charge is the fundamental element in his theory, not electrons. 3. He proposes that photons are the fundamental particles of charge field theory, and both protons and electrons obtain their charge by recycling these photons. 3. Polarity of the charge field. Mathis explains that the charge field's polarity is not due to opposite charges of protons and electrons, but because photons come in two variants, photons and antiphotons, which spin in opposite directions. 4. Earth's charge engine. Mathis argues that Earth acts as a charge engine that draws in photons from the Sun. This incoming charge, composed of both photons and antiphotons, creates a spin imbalance, leading to Earth's magnetic field. 56. The Earth's spin, its spherical shape, and the permeability of its body to photons creates an imbalance of angular momentum, with more at the equator than at the poles. 56. This leads to a net flow of charge out at the equator and in at the poles, creating a charge engine where photons are continuously recycled, generating heat within the Earth. 6. Solar system's journey through the galaxy. Mathis proposes that as the solar system travels through the galaxy, it passes through patches of different charge densities, where photons or antiphotons predominate. 7. The varying ratios of photons to antiphotons as the Earth passes through these patches cause the magnetic field reversal. 7. Solar flips are not true pole reversals. Mathis clarifies that what mainstream science calls a solar flip is not a true reversal of the Sun's poles. These are merely reversals of the solar system field, caused by the changing positions of the outer planets, particularly Jupiter and Saturn, and their charge feedback loop with the Sun. 8910. He provides the example of Jupiter and how its position relative to the Sun affects the perceived charge from the Sun's perspective, leading to apparent reversals every 6 years. 9. Field strength variations. Mathis explains that the varying magnetic field strength observed during reversals is due to the transition between patches of differing charge density. As the solar system moves from a photon-dominated area to an antiphoton-dominated area, it passes through a zone of near equality, leading to a near-zero magnetic field until it enters the next patch. 11. No need for spin or planetary flip. Mathis argues that Earth does not have to stop spinning or physically flip during a reversal. The relative numbers of photons and antiphotons change, but the overall mechanics remain the same. 12. The Earth will always be oriented to the Sun and outer planets, due to their stronger charge fields, so a complete flip would require a major planetary collision. 13. Increased solar magnetism during short-period flips. Mathis attributes the increased solar magnetism during short-period flips to the interactions of returning charge streams from Jupiter and Saturn with the Sun. 13. He explains that opposing photon streams from these planets can spin up each other, leading to increased magnetism. 13. Mathis believes that understanding these charge interactions is crucial to explaining a wide range of phenomena, including magnetic reversals. He criticizes mainstream science for overlooking the role of the charge field and relying on inadequate theories like fluid dynamics or quasi-particles. Copy_all. Thumb_up. Thumb_down. Keep_pin saved to note. What evidence does Miles Mathis provide to explain why gravity cannot be a function of charge? Mathis evidence against gravity as a function of charge. Miles Mathis maintains that gravity and charge are distinct, separate forces that cannot be explained by each other, even though they can be unified. In 1, he argues that if gravity were solely a function of charge, there would be only one fundamental force in the universe. While acknowledging that charge pressure exists from celestial bodies, Mathis contends that it cannot replace gravity for several reasons. Insufficient strength. Mathis posits that charge pressure alone cannot account for gravity's observed strength too. In 3, Mathis claims that based on his calculations, the charge field is 1,000 times weaker than gravity on Earth's surface, a figure he considers an underestimate due to factors like the spin imbalance between photons and antiphotons and the presence of downward-moving photons from sunlight. He argues this difference in strength would make it impossible for charge pressure to fully explain the effects of gravity. Opposing vectors. Mathis proposes that the charge field's primary vector on Earth's surface is upward, due to Earth's charge recycling process where incoming charge is funneled through the poles and emitted near the equator too. He argues this directly contradicts the downward vector required for charge pressure to simulate gravity. Lack of spin component. Mathis highlights that gravity, unlike charge or electromagnetism, exhibits no spin component for. In his theory, spinning charge photons create magnetic fields. While magnetic fields can appear flat when equal numbers of left and right spinning photons cancel each other out, gravity does not exhibit such a cancellation mechanism. He illustrates this using the example of a dropped ball bearing, which falls straight down due to gravity, while a rolled ball bearing experiences minimal resistance due to the lack of a significant spin component affecting its motion. 5. Mathis contends that if gravity were a function of charge, the ball bearing should experience noticeable resistance due to the spin imbalance in the charge field. He further asserts that if gravity were a side effect of incoming charge, the spin effect should be readily observable, significantly affecting the ball bearing's rolling motion. 3. Inconsistent with observed phenomena, Mathis points to several phenomena that contradict the notion of gravity as a function of charge, including unbalanced aurorae. The asymmetrical nature of auroras, which he attributes to a spin imbalance in the charge field, challenges the idea of random spin in incoming charge. 6. Beta decay. Mathis argues that beta decay, which he suggests is influenced by charge chirality, further supports a non-random distribution of photon spin. 6. Mathis acknowledges that there are experiments that show objects responding to charge spin, but he claims that these responses are weak and only detectable at very small scales. 3. This, he argues, is incompatible with the idea that gravity is a direct consequence of incoming charge. If that were the case, the spin effects should be far more prominent and easily observed, similar to how magnetism is a readily apparent effect of the electric field. Despite his firm stance against gravity being a function of charge, Mathis emphasizes that he is open to exploring this possibility further. 7. However, he maintains that based on current evidence from both equations and empirical data, a dual field model where gravity and charge act as separate forces is more plausible. Copy_all. Thumb_up. Thumb_down. Keep_pin saved to note. What are Miles Mathis's main arguments for the existence of a separate charge field and its relationship to gravity? Arguments for a separate charge field and its relationship to gravity. Miles Mathis posits the existence of a separate charge field, distinct from gravity, and argues that it plays a critical role in shaping various phenomena in the universe. Here are his main arguments. Charge is fundamental. Mathis consistently emphasizes that charge, rather than electrons, is the fundamental element in his theories. 12. He identifies photons as the foundational particles of this charge field theory, suggesting that both protons and electrons derive their charge by recycling these photons. 12. The equation for fundamental charge, E equals 1.602 x 10 to 19 c, supports this concept by implying that the proton recycles 19 times its own weight in charge every second, aligning with his assertion that 95% of the universe's mass is photonic, with only 5% being baryonic. 1. Charge recycling mechanism. Mathis proposes a model where celestial bodies, from electrons to galaxies, function as charge engines. 3, 4, 5, 6, 7. These bodies draw in charge, primarily photons, at their poles and release it near their equators, creating a continuous cycle of charge movement. Mathis theorizes that this recycling mechanism is driven by the spin of these bodies and the resulting difference in angular momentum between their poles and equators. 35. Charge as a driving force. Mathis argues that the charge field is not merely a passive entity but a dynamic force that shapes various phenomena. He attributes a wide range of effects to the influence of the charge field, including galaxies in rings. Mathis argues that the observation of dwarf galaxies arranged in rings around larger galaxies like Centaurus A, Andromeda, and the Milky Way, is a strong indicator of the charge field's influence. 89. He suggests that the charge recycling profile of these massive galaxies extends far beyond their visible edges and creates patterns of charge distribution that would naturally lead to the formation of these rings. 89. Planetary rings and other features. Mathis extends the charge recycling model to explain features like the equatorial rings of planets in the solar system and the ring-like distribution of the solar system itself around the Sun. 1011. He questions why these rings predominantly form at the equators and not in other orientations like polar rings, suggesting that gravity alone cannot adequately explain these patterns. 1011. He argues that the charge recycling process, with its focus on equatorial emission, provides a more compelling explanation. 1011. Earth's magnetic field. Mathis challenges the conventional explanation of Earth's magnetic field arising from a spinning iron core. 4. He proposes that Earth's magnetic field originates from the charge recycling process, where photons, spinning either left or right, photons and antiphotons, are channeled through the Earth. 451213. He suggests that the interaction and spin dynamics of these photons, particularly those traveling from pole to pole, generate the magnetic field. 45131415. He further posits that the dominance of photons over antiphotons in the Earth's vicinity creates a net spin imbalance, contributing to the strength and orientation of the magnetic field. 45131415. Magnetic reversals. Mathis rejects the mainstream explanation of magnetic reversals being caused by fluid dynamics in Earth's core. 1617. He argues that reversals occur due to the solar system's movement through patches of varying charge densities in the galaxy. 18. As the Earth passes through these patches, the ratio of photons to antiphotons fluctuates, leading to shifts in the spin dynamics of the charge field and causing magnetic reversals. 1819. He explains that periods of near-zero magnetism during reversals occur when the Earth transitions between photon-dominated and antiphoton-dominated regions, leading to a temporary balance in the charge field. 19. Negative thermal expansion. Mathis offers a novel explanation for negative thermal expansion, a phenomenon where some materials contract upon heating. 202122. He challenges the mainstream's reliance on complex theoretical constructs like rigid unit modes and transverse vibrational modes and posits that negative thermal expansion is a direct consequence of charge dynamics. 23. He suggests that rising temperatures correspond to increased charge densities. 22. He argues that certain materials, when heated, experience an increase in through charge, meaning more charge flows directly from pole to pole within their nuclei and atoms. 24-25. This increase in through charge, according to Mathis, leads to a tightening of the molecular structure, resulting in contraction despite the increased temperature. 24-25. Gravity as a separate force. While acknowledging the intimate connection between charge and gravity, Mathis maintains that they are distinct forces, each with its unique properties. 262728. He argues that while both fields can be unified mathematically, one cannot be solely explained by the other. He asserts that although charge pressure exists from celestial bodies, it is not powerful enough to account for the effects of gravity. 2729. He also points to the lack of a spin component in gravity, a feature inherent to his charge field model, as further evidence that gravity is a separate force. 30-31. Despite his current stance, Mathis acknowledges the incompleteness of his own theories of gravity and expresses a willingness to consider alternative explanations if supported by sufficient evidence. 28. Mathis's theory of a separate charge field offers an alternative interpretation of various physical phenomena. However, it is important to note that his ideas have not been widely accepted within the mainstream scientific community, and his claims should be evaluated with critical thinking. Copy_all. Thumb_up. Thumb_down. Keep_pin saved to note. What are Miles Mathis's arguments for the existence of a separate charge field, distinct from the gravitational field, and how does it affect the Earth's poles? The charge field's effects on Earth's poles. Miles Mathis argues for a distinct charge field separate from the gravitational field, asserting that this field significantly influences Earth's poles. He contends that celestial bodies, including Earth, operate as charge engines, drawing in charge primarily composed of photons at their poles and emitting it most intensely near their equators. 1. This continuous charge movement, according to Mathis, is driven by the spin of these bodies and the resulting differences in angular momentum between poles and equators. 23. Charge recycling and magnetic poles. Mathis challenges the traditional explanation of Earth's magnetic field as originating from a spinning iron core. He proposes instead that Earth's magnetism is a direct consequence of this charge recycling process. 4. He posits that photons, the fundamental particles of his charge field theory, carry real mass and spin, and their movement and interactions create the magnetic field. 5. Specifically, Mathis argues that Earth pulls in charge photons from the Sun, absorbing them at its poles and re-emitting them, most strongly at 30 degrees north and south latitude. 6. The constant flow of spinning photons creates a vortex at each pole, with the incoming charge interacting with the Earth's existing spin to produce a net magnetic effect. 78. This model, Mathis claims, offers a more compelling explanation for several observed phenomena than conventional theories. Wandering magnetic poles. the position of Earth's magnetic poles is not static but shifts over time. Mathis attributes this to the dynamic nature of the charge field, which is influenced by a variety of factors, including variations in solar charge. The amount and intensity of charge emitted by the Sun can fluctuate, impacting the strength and direction of the charge vortex at Earth's poles. 9. Influence of Jovian planets. Mathis highlights the role of the four large outer planets, Jupiter, Saturn, Uranus, and Neptune, in shaping Earth's charge field. These planets, he argues, also return charge to the Sun and Earth, and their varying positions affect the overall charge dynamics in the solar system. 9. Galactic charge. Mathis suggests that the Earth is also influenced by charge coming directly from the galactic core, further contributing to the dynamic and shifting nature of the charge vortex at its poles. 9. South Pole anomalies. Mathis uses the example of the Wilkes Land anomaly in Antarctica, a region exhibiting an unexplained increase in gravity, to further support his charge field theory. 10. He argues that the anomaly is not due to increased mass or a hidden impact crater, as mainstream theories suggest, but rather a result of the concentrated charge vortex entering the Earth at this location. 7-11. Strength of South Pole vortex. Mathis observes that the South Pole vortex appears to be stronger than the North Pole vortex. 7. He explains this asymmetry as arising from the composition of the ambient charge field in Earth's vicinity. Based on observations of electron and positron tracks, Mathis concludes that this field contains approximately twice as many photons as antiphotons. 12. Since photons preferentially enter the South Pole, this imbalance leads to a stronger charge flow and a more pronounced magnetic effect in the southern hemisphere. The charge field's relationship to gravity. While Mathis maintains that the charge field plays a significant role in shaping Earth's magnetic poles, he distinguishes it from the force of gravity. He acknowledges a connection between the two but asserts that one cannot be fully explained by the other. 13. He argues that charge pressure alone is not strong enough to account for gravity's observed strength. 14-15. Mathis further points to the lack of a spin component in gravity, a characteristic inherent in his model of the charge field, as evidence that the two forces operate independently. 16. He observes that objects falling under the influence of gravity do not exhibit the kind of rotational behavior one would expect if they were interacting with a field of spinning photons. 17-18. Despite his firm belief in a separate charge field, Mathis acknowledges the need for further exploration to fully understand the relationship between charge and gravity. He expresses a willingness to consider alternative explanations, including the possibility of gravity being a function of charge, if compelling evidence emerges. 19. Copy_all. Thumb_up. Thumb_down. Keep_pin. Save to note. What are Miles Mathis's arguments against gravity being a function of charge? Arguments against gravity as a function of charge. Miles Mathis, despite acknowledging a connection between the charge field and gravity, argues against the idea that gravity is solely a function of charge. He presents several reasons for his stance, drawing on his observations and analysis of various physical phenomena. Gravity's strength. Mathis contends that charge pressure from celestial bodies, while present, is not sufficiently strong to account for the observed effects of gravity. 12. He posits that gravity exerts a significantly stronger force than can be reasonably explained by charge pressure alone. Vector directions. Mathis's model suggests that the primary vector of the charge field at the Earth's surface is upwards, due to the charge recycling process. 2. This rising charge field is responsible for buoyancy, lift, and the levitation of the atmosphere. However, for charge pressure to act as gravity, it would require a downward vector. The opposing directions of these vectors contradict the notion of charge pressure as the sole source of gravity. Absence of a spin component in gravity. A key distinction between the charge field and gravity, according to Mathis, is the presence of a spin component. He emphasizes that all photons in the charge field possess spin, which contributes to the creation of magnetic fields. 3. However, gravity, as observed, does not exhibit any such spin component. If gravity were solely a function of charge, Mathis argues, it should also manifest a spin component, similar to magnetism, which is closely associated with the electrical field. The lack of this spin component in gravity weakens the argument for its origin as a charge-based force. Rolling resistance. Mathis uses the example of a rolling ball bearing to illustrate the discrepancy between charge and gravity. 4. He points out that a ball bearing rolling on a surface experiences minimal resistance, unlike the strong resistance encountered when rolling spherical magnets against each other. He attributes this difference to the spin alignments inherent in magnetism. If gravity were a function of charge, Mathis argues, rolling objects should encounter significant resistance due to the spin interactions of the charge field, akin to the behavior of magnets. The observed ease of rolling contradicts this expectation. Magnitude of spin effects. Mathis calculates that the charge field is significantly weaker than gravity on the Earth's surface. 5. He estimates the spin effect of charge to be roughly 1/10,000th the strength of gravity. If gravity were primarily a consequence of incoming charge, Mathis argues, we should observe more pronounced spin effects in everyday phenomena. For instance, He predicts that a ball bearing dropped through a charge field should exhibit a noticeable curve due to the summed spin of the field. However, such effects are generally not observed, suggesting that the influence of charge spin is much weaker than would be expected if it were the primary driver of gravity. Mathis uses these arguments to support his position that gravity, while interconnected with the charge field, cannot be entirely explained by charge alone. He maintains that the observed characteristics of gravity, particularly its strength, vector direction, and lack of a spin component, point towards a separate and distinct force. Copy_all. Thumb_up. Thumb_down. Keep_pin saved to note. Explain Miles Mathis's argument against the mainstream's explanation for the fractional quantum Hall effect. Mathis's critique of the fractional quantum Hall effect explanation. Miles Mathis strongly criticizes the mainstream explanation for the fractional quantum Hall effect, FQHE, arguing that it relies on convoluted mathematical tricks and ignores the fundamental role of the charge field. He outlines his criticisms in the fractional quantum Hall effect 1. Ignoring the charge field and nuclear structure, Mathis contends that mainstream physicists fail to adequately consider the influence of the charge field, composed of real photons, in their explanations of the FQHE. He criticizes their reliance on abstract mathematical models that disregard the physical reality of the charge field and its interactions with the atomic nucleus. Mathis emphasizes the importance of understanding nuclear architecture and the specific ways in which the nucleus channels charge, arguing that these factors are crucial for explaining the observed phenomena 234. He suggests that the nucleus of the specific elements involved, bismuth or arsenic, should be considered, but the mainstream explanation overlooks these details. 3. Reliance on quasi-particles and mathematical fudges. Mathis dismisses the mainstream explanation's use of quasi-particles, such as composite fermions, as artificial constructs invented to compensate for the shortcomings of their theories. He argues that these quasi-particles lack empirical support and are merely mathematical placeholders used to force-fit the data into their models. 56. He criticizes physicists like Landau for consistently resorting to quasi-particles and other mathematical tricks to avoid acknowledging the real photon and its role in these phenomena. 4. Misinterpreting electron density. Mathis challenges the mainstream's focus on electron density as the primary factor determining the quantization observed in the FQHE. He argues that the fractions arise from the frequencies or densities of photons, not electrons. He points out that electrons primarily act as carriers within the charge field and their density would not significantly affect the quantization, especially at low temperatures where electron densities are inherently low. 78. Overlooking the complexity of the charge field, Mathis highlights the oversimplification of the charge field in mainstream explanations. He points out that they often fail to account for the various components and interactions within the charge field, including incoming and outgoing fields, the interplay between charge entering and leaving the system, ambient and intrinsic fields, the distinction between the surrounding charge field and the charge field associated with the material itself, the Earth's charge field, the potential influence of Earth's own charge field on the experimental setup, anti-charge, the presence and role of antiphotons, which the mainstream often ignores. Mathis argues that these oversights prevent a complete and accurate understanding of the FQHE. Unwinding the basic equation, Mathis dissects the fundamental equation used to describe the FQHE, R equals H/E2V, where R is the Hall resistance, H is Planck's constant, E is the fundamental charge, and V is an integer or fractional value. He emphasizes that H, rather than being a mysterious constant, represents the real charge photon with a calculable mass. He also points out that E, often taken to represent the fundamental charge, is specifically the charge of the electron and not necessarily the fundamental unit of charge. Mathis suggests that the electron itself can be removed from the equation entirely, focusing instead on the charge photon as the fundamental entity. 79. The significance of V. Mathis points to the variable V, which takes on fractional values, as the key to understanding the FQHE. He notes that while the mainstream acknowledges its significance, they fail to provide a clear physical interpretation for it, often resorting to vague terms like divisor or filling factor of Landau levels. Mathis emphasizes that V should be directly related to the frequency of the charge field and its associated photon. 7. Alternative explanation for the denominator of 2. Mathis offers a possible explanation for the appearance of the fraction 5/2 in the FQHE, a value that puzzles mainstream physicists. He proposes that the denominator of 2 might arise from the proportion of pole-to-pole charge flow. At certain temperatures, the amount of charge flowing directly from pole to pole within the material might equal the amount flowing from pole to equator, resulting in a half fraction. The imbalance of photons and antiphotons, the Earth's ambient charge field, according to Mathis, consists of approximately twice as many photons as antiphotons. This inherent imbalance could contribute a factor of 2 to the observed fractions. Mathis suggests that further investigation into these possibilities, within the framework of his charge field theory, could lead to a more comprehensive and mechanically sound explanation of the FQHE. Overall, Mathis argues that the mainstream explanation for the FQHE is inadequate and relies on artificial constructs like quasi-particles and convoluted mathematical manipulations. He advocates for a shift in focus towards the charge field, nuclear architecture, and the real physical interactions of photons, emphasizing that these factors hold the key to a more accurate and comprehensive understanding of the phenomenon. Copy_all. Thumb_up. Thumb_down. Keep_pin saved to note. What does Miles Mathis claim is the cause of the rings of heat at 30 degrees north and south? Mathis's explanation for rings of heat at 30 degrees north and south. While Mathis doesn't explicitly address rings of heat in the provided sources, his model of charge recycling by celestial bodies offers a potential explanation for this phenomenon. Charge recycling as a universal engine, Mathis proposes that all celestial bodies, from electrons to galaxies, function as charge engines. This means they absorb charge, primarily photons, at their poles and re-emit it, most intensely at their equators. This process creates a continuous flow of charge, or a charge field, both within and around these bodies. Charge field as a source of heat, Mathis asserts that charge photons are synonymous with heat. Therefore, the areas where charge is most intensely emitted would experience higher temperatures. This is supported by his explanation for Uranus's hot upper atmosphere, 12, which he attributes to charge friction caused by the release of charge into an opposing field. Earth's charge recycling and 30-degree latitudes, Mathis states that Earth's charge recycling process doesn't strictly favor the equator. Instead, the most intense emission of charge, and therefore heat, occurs around 30 degrees north and south latitude, 3. This is likely due to a combination of factors. Spin dynamics, Earth's rotation and the resulting angular momentum create a complex charge flow pattern. Magnetic field interactions, the Earth's magnetic field, also generated by charge recycling, influences the direction and intensity of charge flow. External charge sources, the Earth is constantly bombarded by charge from the Sun and other celestial bodies, further shaping the charge field. Potential formation of heat rings, if the areas around 30 degrees north and south latitude are indeed the primary points of charge emission from Earth, this could explain the formation of rings of heat at these latitudes. These areas would experience a greater influx of charge photons, leading to higher temperatures compared to the surrounding regions. This would create a distinct temperature band or ring around the globe. It's important to note that Mathis doesn't directly mention rings of heat in these sources. He primarily focuses on explaining individual phenomena like the Earth's magnetic field, Uranus's hot upper atmosphere, and various quantum effects. However, his model of charge recycling and its connection to heat generation offers a potential framework for understanding the existence of these rings, based on the following logic. 1. Charge photons are equivalent to heat. 2. Earth re-emits charge most intensely at 30 degrees north and south. 3. Therefore, these latitudes would experience higher temperatures, potentially forming rings of heat. Further research and analysis, building upon Mathis's theories, would be needed to definitively link his charge recycling model to the phenomenon of rings of heat. Copy_all. Thumb_up. Thumb_down. Keep_pin saved to note. What evidence does Miles Mathis present to refute the mainstream theory of the Earth's magnetic field reversal? Mathis's challenge to mainstream magnetic field reversal theory. Miles Mathis, in Pole Reversals as Proof of My Charge Field 1, directly refutes the mainstream theory explaining the Earth's magnetic field reversals. He argues that the mainstream explanation, based on fluid dynamics in the Earth's molten core, is inadequate and proposes an alternative explanation based on his charge field theory. Critique of core dynamics explanation, Mathis dismisses the mainstream's reliance on core dynamics as a dodge too because it is difficult to verify and lacks a clear mechanism. He argues that there is no evidence to support the claim that fluid movements within the Earth's core can generate the necessary magnetic field reversals. He points out that even the impact event that led to the Cretaceous extinction, a significant geological event, did not trigger a magnetic reversal, casting doubt on the impact event trigger hypothesis 2. Charge field as the fundamental source, Mathis posits that the Earth's magnetic field, and its reversals, are fundamentally driven by the charge field, a field composed of real photons with mass and spin 3. He argues that the mainstream fails to explain the origin of the Earth's magnetic field because they lack a proper understanding of the charge field and its dynamics. Photon/antiphoton imbalance and spin, Mathis's theory hinges on the concept of photons and antiphotons, particles of light with opposite spins. He claims that the Earth's ambient charge field contains an imbalance of these particles, with photons outnumbering antiphotons by approximately 2:1:4. This imbalance, according to Mathis, leads to a net spin in the charge field, which in turn generates the Earth's magnetic field. Charge recycling and field generation, Mathis describes a process of charge recycling 5 wherein the Earth, like all celestial bodies, acts as a charge engine. This engine draws in photons at its poles and re-emits them most strongly at the equator, creating a continuous flow of charge. The spin of the Earth, combined with the angular momentum generated by this charge flow, further contributes to the magnetic field's strength and orientation. Solar System's galactic journey and patchy charge fields. Mathis attributes the magnetic field reversals to the Solar System's movement through the galaxy 6. He proposes that the galaxy contains patches with varying concentrations of photons and antiphotons. As the Solar System traverses these patches, the Earth encounters shifting proportions of photons and antiphotons, leading to fluctuations and eventual reversals in the Earth's magnetic field. Distinguishing solar flips from Earth's reversals, Mathis addresses the observation that the Sun's magnetic field flips approximately every 9 to 12 years while the Earth's reversals occur on much longer time scales. He clarifies that the observed solar flips are not true pole reversals but rather reversals in the Solar System Field 7, a magnetic field generated by the interaction of the Sun's charge field with the charge fields of the outer planets, primarily Jupiter 8. Field strength variations during reversals. Mathis explains the observed weakening of the Earth's magnetic field during reversals as a consequence of the Solar System passing through regions of near-equal photon and antiphoton concentrations 9. In these regions, the charge field's net spin diminishes, leading to a weakened magnetic field. As the Solar System moves into a new patch with a dominant photon or antiphoton population, the magnetic field gradually strengthens and re-establishes its polarity. Mathis's theory provides a comprehensive explanation for the Earth's magnetic field reversals, linking them to the fundamental properties and dynamics of the charge field. He challenges the mainstream focus on core dynamics, arguing that it lacks the necessary explanatory power and relies on unverifiable assumptions. His charge field model offers an alternative framework that directly addresses the origin of the magnetic field, its polarity, the observed field strength fluctuations, and the seemingly random intervals between reversals. Copy_all. Thumb_up. Thumb_down. Keep_pin saved to note. What specific mechanism does Miles Mathis propose for Earth's magnetic field reversals? Earth's magnetic field reversals. Mathis's charge field explanation. Mathis's explanation for Earth's magnetic field reversal centers on the concept of a charge field, a universal field composed of photons and antiphotons, which are particles of light with opposite spins. According to Mathis, these particles drive the magnetic fields of all celestial bodies, including the Earth, through a process called charge recycling. The charge engine. Mathis proposes that all celestial bodies function as charge engines. 1. They absorb charge, mainly in the form of photons, at their poles and re-emit it most intensely at their equators. 1. This creates a continuous flow of charge, shaping both the internal and external magnetic fields of the celestial body. 1. Earth's charge imbalance. In the case of the Earth, the ambient charge field contains a greater proportion of photons than antiphotons, roughly a 2:1 ratio 2. This imbalance results in a net spin in the charge field surrounding the Earth, which in turn generates the Earth's magnetic field. 2. Solar System's galactic journey. Mathis suggests that the Solar System's movement through the galaxy plays a crucial role in magnetic field reversals. He proposes that the galaxy is not homogeneous in its charge distribution, instead, it contains patches with varying concentrations of photons and antiphotons. 3. As the Solar System travels through these patches, the Earth encounters shifting proportions of photons and antiphotons. 3. Mechanism of reversal. When the Earth encounters a patch with a significantly different photon/antiphoton balance, it disrupts the established charge flow and weakens the existing magnetic field. 4. During this transition, the Earth's magnetic field weakens considerably, potentially dropping to as low as 5% of its normal strength. 5. As the Solar System moves further into the new patch, the Earth's charge engine gradually adapts to the new dominant charge, and the magnetic field strengthens, but with reversed polarity. 4. Random reversal intervals. The seemingly random intervals between reversals are explained by the varying sizes and distributions of these charge patches within the galaxy. 3. The duration the Solar System spends in a particular patch, and thus the time between reversals, is unpredictable. 3. Distinction between solar flips and Earth's reversals. While the Sun also exhibits magnetic field flips roughly every 9 to 12 years. 5. Mathis distinguishes these events from the Earth's full magnetic field reversals. He clarifies that the observed solar flips are not true pole reversals but rather reversals in the Solar System Field 6. This field arises from the interaction between the Sun's charge field and those of the outer planets, particularly Jupiter 6. The shifting positions of these planets relative to the Sun lead to periodic reversals in the Solar System field, which the mainstream mistakenly interprets as solar pole flips. 6. Mathis's charge field theory provides a coherent explanation for Earth's magnetic field reversals by linking them to the fundamental dynamics of the charge field and the Solar System's movement through the galaxy. He emphasizes that charge, not just fluid dynamics within the Earth's core, is the driving force behind these phenomena. His model directly addresses the origin of the magnetic field, its polarity, the observed field strength fluctuations, and the seemingly random intervals between reversals. Copy_all. Thumb_up. Thumb_down. Keep_pin saved to note. Listen to 22 Minutes podcast by Notebook. May I review of Miles Mathis charge field articles. Mathis%20 Transcript to 22 minutes notebook AI podcast articles review of Miles Mathis charge field. Ever get that feeling, like, when you're putting together a puzzle and there's this one piece, it just doesn't quite fit, and you start to think, maybe we're missing a big chunk of the picture. I know that feeling. And it's not just any puzzle. Right? It's the puzzle of the universe. How it all works, the fundamental stuff. Today, we're diving into some pretty mind-bending territory with this guy, Miles Mathis. He's an independent researcher, and he's basically saying, hold on. What if we've got physics all wrong? Yeah. Mathis, he's definitely not afraid to ruffle some feathers. That's for sure. And look, we're here because, let's be honest, sometimes those textbook explanations, they just don't cut it. You know, like, why do magnets actually attract things? What's the deal with that? It's that curiosity, that desire to dig deeper. That's what drew us to Mathis' work in the first place. I mean, the guy's written tons of papers, and they all revolve around this thing he calls the charge field. The charge field. Okay. So is this, like, the next big scientific revolution we're talking about here, or is it more like, let's just say his ideas, they haven't exactly made it to the mainstream yet. Right. Controversial is maybe the word. Yeah. You could say that. Here's the thing. Sometimes, even those ideas that sound a little out there, they can make us rethink things, maybe spark a new way of looking at the universe. Okay. So riddle me this then. What exactly is this charge field? Break it down for us. At the core of it, Mathis is saying that everything in the universe, and I mean everything, is constantly swapping these little bits of light. And get this, he believes they actually have mass. Spinning photons, he calls them. Spinning photons with mass. That's not what they taught me in school. Exactly. And this whole exchange, it's not random. Mathis believes this constant flow of photons, this back and forth, this is what creates what we observe as charge. So instead of just saying electricity, it exists. He's saying there's this whole intricate behind-the-scenes dance of light particles driving the show. Exactly. It's like a cosmic dance floor, and these photons are the dancers. And because he's starting with this constant exchange of photons, it leads him to some pretty radical conclusions about, well, everything. Okay. I'm hooked. Give me an example. Alright. Let's take something we've all experienced, something that just is. The Earth's magnetic poles. They flip. Right? Every now and then, they just decide to switch places. Yeah. North becomes south, south becomes north, the whole shebang. Right. Now the usual explanation is all about these complex fluid movements deep down in the Earth's core. Hard to wrap your head around, even harder to prove or disprove for that matter. Yeah. It's like trying to imagine what's happening in the center of a cake while it's baking. Exactly. So, Mathis, he comes at it from this charge field perspective. Yep. He connects those flips to the movement of our whole solar system as it travels to the galaxy. Okay. Hold on. Are you saying our solar system is like a cosmic ship, and those magnetic pole flips? Those are, like, hitting some rough patches of space. It's not that far off. See, Mathis, he doesn't think space is all uniform like this calm empty sea. He says it has different concentrations of, you guessed it, those spinning photons and what he calls anti-photons, which are basically photons spinning the other way. Spinning the other way. So, like, clockwise versus counterclockwise. You got it? And when our solar system drifts through an area with a higher concentration of these anti-photons, well, that's when things get interesting. He thinks it messes with the Earth's charge flow, causing those poles to flip. So it's like we're on this cosmic roller coaster, and every now and then, we hit a loop-de-loop and our magnetic field goes haywire. That's the basic idea, and this all feeds into Mathis' big picture. He says everything in the universe from tiny atoms to planets to, well, us, we're all acting like these charge engines. We pull in photons at the poles and release them at the equator. It's like a constant flow, a cosmic inhale and exhale. Okay. So we've gone from these tiny particles to planetary poles to the entire universe being this giant breathing charge-filled system. This is a lot to unpack. It definitely challenges how we usually think about things, But that's what's so intriguing about Mathis' work. He's not just tweaking things here and there, he's offering a completely new lens to view the universe through. Okay. I'm starting to get the gist of this charge field idea, but how about a concrete example of it in action, something we can really sink our teeth into? Alright. Let's talk about Uranus, you know, that ice giant way out there. Yes. Uranus, the butt of all the planetary jokes. What about it? It's actually a perfect example of what we're talking about. Based on its distance from the sun, it should be pretty darn cold. But here's the thing, it's got this unexpectedly toasty upper atmosphere, like, way hotter than it should be. It's like finding a furnace blasting heat in the middle of Antarctica. Doesn't quite add up. Right. And the typical explanation, well, it involves these hypothetical giant impacts way back in its history. The problem is it's pretty hard to make that fit with what we actually observe. Sounds like trying to explain a hailstorm by saying a butterfly flapped its wings in Brazil. Exactly. Now, Mathis, he sees this as another piece of evidence for his charge field idea. He thinks Uranus' heat is a side effect of how it's interacting with space, specifically with this charge field. He compares it to how electric currents generate heat. Wait. You're saying Uranus is like a giant space heater, and it's all thanks to these spinning photons? You're getting it? Mathis, he takes these photons seriously. He sees them as real physical things that carry energy, and when they interact, well, things heat up just like friction does here on Earth. So maybe Uranus' weird temperature, it's not so weird after all if you look at it through this charge field lens. But if everything's exchanging these photons, why isn't the entire universe as hot as a furnace? That's the $1 million question, isn't it? And this is where Mathis gets into how this charge field interacts differently depending on the size and structure of an object. It's all about scale. Okay. So we've got Uranus as this big cosmic example, but what about something a little closer to home, something we can relate to? Okay. How about something you can probably find in your backyard? A spider web. Spider webs. Alright. I'm intrigued. What do those silky threads have to do with Uranus and the fate of the universe? It's not so much the web itself, but what it lets spiders do with it? You know, that whole flying thing. Oh, right. Like, how do they just float through the air like that? I always thought it was something to do with wind catching the web. That's part of it, for sure. The traditional explanation involves updrafts and those silk threads and maybe some static electricity mixed in, but Mathis, well, he sees those ballooning spiders as another example of his charge field in action. Hold on. Are you saying those tiny spiders are somehow hitching a ride on this cosmic charge field? Essentially. Yeah. He believes they're riding the upward flow of those spinning photons we talked about, the ones near the Earth's surface. So those same photons that might be creaking Uranus are also giving spiders a lift. That's wild. It does sound crazy. Right? But imagine it like this. This constant flow of photons going up, it's like a subtle wind, a photon wind. And a tiny spider with its web is light enough to be lifted by it. So they're basically surfing on a wave of photons. It's a pretty cool visual. But hold on. If that's the case, why don't we see, I don't know, squirrels floating away every time the wind blows? That's where scale comes in. Mathis says the strength of this charge field effect, it changes depending on the size and makeup of an object. A spider, it's super light compared to its surface area. So like a tiny sailboat catching the wind versus a big heavy cruise ship. Exactly. Your average squirrel, even with a bushy tail, it's not gonna be affected by this subtle force in the same way. Okay. So we've got cosmic currents flipping planetary poles, spiders hitching rides on photon winds. Is there anything this charge field doesn't influence? Well, Mathis would argue that it's behind everything, even gravity itself. Wait. Gravity, you mean the thing that keeps us from floating off the planet, that gravity? The one and only. Now I know you're thinking, gravity is like physics 101. It's what holds the entire universe together. But even today, we don't fully understand it. Mathis suggests that gravity, it's not a force in itself, but more like a side effect of this charge field, like a shadow it casts. Okay. I'm officially lost. How can gravity be a side effect? Think of it like this. Instead of gravity being this invisible pull between objects, Mathis pictures it more like we're being pushed together by the sea of photons, this constant exchange of charge. So it's not a pull, it's a push. My head's spinning. It's a different way of picturing it. I know. He argues this constant flow of charged photons. It creates a kind of pressure. And that pressure, it acts a lot like what we perceive as gravity. Alright. I'm gonna need a minute to process this. But if gravity is just a side effect, why haven't we noticed this before? Mathis would say it's because compared to electromagnetism, gravity is actually a pretty weak force. We only really feel it because it all adds up, especially with really massive objects like planets. So gravity is like the shy cousin of electromagnetism, always lurking in the background, but not quite as flashy. Something like that. But according to Mathis, both are connected to this underlying web of photon interactions. Okay. So we've gone from spiders to a whole new theory of gravity. Is there anything else Mathis uses this charge field to explain? Head down south, way south to Antarctica. There's a place called the Wilkes Land anomaly. The Wilkes Land anomaly. Sounds ominous. It's a region where gravity acts a bit, well, weird. It seems to be stronger there than it should be based on what we know about the Earth's mass. Stronger gravity. You mean, like, if I go there, I'll suddenly weigh twice as much? Not quite that dramatic. It's a very slight variation, something you wouldn't feel, but our instruments can detect it. Now the usual theory is there's a massive impact crater buried beneath all that ice. So something slammed into the Earth there a long time ago, and that's messing with gravity. That's the idea, but it's tough to prove without, digging up all of Antarctica. I can see how that might be a problem. So what does Mathis say about this gravity glitch? He sees it as another clue pointing to the charge field. He says, what we're seeing, it's not so much a gravity anomaly, but the effect of this intense stream of charged photons entering the Earth right at the South Pole. Hold on. So instead of a buried crater, it's just a beam of photons hitting the Earth like a cosmic ray gun. Essentially, remember, he sees everything as these charge engines. And in his model, the Earth pulls in these photons at the poles with the South Pole being a major entry point. Okay. I'm starting to see how this might works. Everything points back to this charge field, but let's zoom back in for a second. You mentioned spiders earlier, how this charge field might be influencing things on a really tiny scale. Any other examples of that? Mathis argues that our current models of how energy gets transferred, they're actually way less efficient than they could be. Any points is something we all learned about in school, photosynthesis. Photosynthesis. You're saying plants are somehow tapping into this charge field for energy? I thought it was all about sunlight and chlorophyll. That's the traditional explanation. But Mathis believes plants are much more sophisticated than we give them credit for. He thinks they're channeling charge, those spinning photons, with incredible efficiency. So instead of just soaking up sunlight, plants are like plugging into the universe's power grid. That's a simplified way of putting it, but you're getting the idea. He believes they have these specific pathways, even at the atomic level, that allow them to capture and use this charge energy. Wow. So plants are like tiny, green, super efficient solar panels. That's amazing. And this is where things get really interesting. Because Mathis says, if we could unlock the secrets of how plants do this, it could revolutionize how we produce energy. Imagine harnessing the charge field directly. Clean, limitless energy from thin air. It sounds too good to be true. It might sound like science fiction, but Mathis argues that nature, especially in the form of plants, has already figured it out. He thinks our current energy models are missing a huge piece of the puzzle. Okay. Now you're really blowing my mind. So we've got plants acting like cosmic antennas, spiders, surfing photon winds. What other evidence does Mathis have for this charge field? Let's talk about some strange high-energy particles. Scientists have been picking them up as they exit the Earth's south pole. And get this, they seem to have traveled all the way through the planet. Wait a minute. Particles punching through the entire Earth. How is that even possible? That's what makes it so baffling. We're talking about energy similar to cosmic rays, and those usually don't get very far through our atmosphere, let alone the entire planet. Some scientists are even saying these might be a completely new kind of particle. Okay. So we've got mystery particles breaking the laws of physics. I know what's coming next. Mathis has an explanation, doesn't he? Of course, he does. And you know the punchline. It all goes back to the charge field. He believes these particles are just photons, but they've been channeled through the Earth. Channeled like those pathways in plants we were just talking about. Exactly. He sees the Earth as this giant charge engine pulling in photons at the poles, releasing them at the equator. And these particles, they're just taking a shortcut through the planet's interior. So the Earth is like a giant particle accelerator. That's the general idea. And remember, those particles are being detected exiting the South Pole, which lines up with his theory. Okay. That's pretty clever. But what about the energy levels? Those particles pack quite a punch if they're powerful enough to go through the entire Earth. How does Mathis explain that? Because it's spin up. Remember we talked about photons and antiphotons spinning in opposite directions. Right. Like a cosmic dance-off. Well, Mathis believes that when they collide head-on, they can actually transfer energy to each other, causing them to spin even faster. So the more they collide, the faster they spin, the higher their energy. It's like a cosmic game of photon pinball. Exactly. It's a pretty elegant explanation for how these particles could gain enough energy to punch through an entire planet. Alright. I'll admit, Mathis makes a compelling case. But if this charge field is so fundamental, so influential, you'd think more people would be talking about it. Why isn't it more mainstream? Well, Mathis have the theory about that too. He believes this isn't actually a new idea. He thinks it's been around for centuries, maybe even millennia, hidden in plain sight. Hidden in plain sight? What do you mean? Mathis has noticed some interesting similarities between his own diagrams of the atoms, specifically the nucleus, and some ancient symbols. You're not talking about, like, hieroglyphics or crop circles, are you? Think even older. Things like the flower of life, the hexagram, these geometric patterns that show up in cultures all over the world. Okay. That's interesting. But how are ancient symbols connected to atomic nuclei? Mathis believes these symbols might be representations of the charge field itself. He says their structure mirrors the way he visualizes protons and neutrons arranged within the atom's nucleus. It's like they were trying to represent something fundamental about the universe. So you're saying that ancient civilizations might have had some understanding of this charge field, this hidden force that drives everything? It's a bold claim for sure. But it does make you wonder, were they trying to depict scientific knowledge, or were these symbols representing something more intuitive, something deeper about reality? I'm not sure I'm ready to rewrite history just yet, but I have to admit, the idea that these ancient cultures might have been onto something, it's pretty mind-blowing. That's the thing about Miles Mathis and his work. Whether you agree with his conclusions or not, he makes you think differently. You know, he challenges you to question everything you thought you knew about the universe. He definitely does that. But speaking of questioning everything, there's one thing we haven't really touched on yet, and it feels pretty central to this whole charge field idea: energy. Ah, yes. Energy, the driving force of the universe. What does Mathis have to say about that? Well, he seems to think our current understanding of energy, even with all our fancy quantum physics, is fundamentally flawed. Okay. Now you've got my attention. Right. Tell me more about this radical rethink of energy. Mathis argues that energy, it's not just something we generate or harness from the environment. He sees it as this intrinsic property of the universe itself, all thanks to that constant flow and exchange of charge he keeps talking about. So instead of thinking of energy as separate from us, something we have to extract or create, he's saying it's woven into the very fabric of existence. We're swimming in an ocean of energy all the time. Exactly. And this is where he points to certain phenomena that traditional physics really struggles to explain, things that make perfect sense within his charge field model. Okay. You've got to give me an example. What kind of head-scratching phenomena are we talking about? Let's talk about something called negative thermal expansion. Negative what now? That sounds beta. I know. Right? But it's a real thing. Basically, certain materials, when you heat them up, instead of expanding like they normally do, they actually shrink. Wait. That's the opposite of what's supposed to happen. Heat makes things expand. It's like rule. Tell me about it. It's like basic physics. Right. Okay. But these materials, they just break the rules. Now mainstream science, they try to explain it with complicated models of how atoms vibrate and interact, but Mathis, as you can probably guess, he has a different take. Let me guess, it's the charge field. What else? You got it? He says the traditional explanations, they're missing a crucial piece of the puzzle, and that is the flow of charged photons through the material itself. Okay. I'll bite. How do photons make something shrink when you heat it up? That seems counterintuitive. Mathis argues that the extra energy from the heat, it doesn't just make the atoms vibrate faster, it actually enhances the flow of those charged photons through the material. And this, in turn, changes the balance of forces between the atoms, causing them to pull closer together instead of pushing apart. So it's not just about the atoms themselves, it's about how they're interacting with this invisible sea of photons flowing through them. Exactly. It's all connected. And he sees this as yet another example of how this charge field plays a crucial role in, well, pretty much everything. Okay. I'm starting to feel like this charge field is less like a scientific theory and more like the Force from Star Wars. But unlike the Force, Mathis claims to have actual evidence for his ideas. Right? He does. And one of the places where he sees the strongest evidence is out there in space, specifically comets. Comets. You mean those icy wanderers of the solar system? What do they have to do with any of this? Well, Astronomers have noticed something really weird about some comets. They seem to be active, spewing out gas and dust even when they're super far away from the sun, way farther than they should be for that to be happening. Wait. So they're like those people who wear shorts in the middle of winter, just built different. Something like that. See, comets, they're supposed to be driven by solar heat. The closer they get to the sun, the warmer they get, the more their ice melts, and that creates those beautiful tails we see. But these comets, they're breaking the rules. They're too far away from the sun for that to be happening. Okay. So what's the explanation? How are they defining the laws of physics? Well, mainstream science, they're a bit stumped. They figure there must be some other energy source, some unknown factor that's causing these comets to act this way. But you can probably guess what Mathis thinks. It's the charge field, isn't it? It always comes back to the charge field. You know it? He says those comets aren't just drifting aimlessly through space. They're interacting with this charge field, drawing energy from this vast invisible network that's everywhere. So those comets are like cosmic surfers riding the waves of the charge field. That's a great way to put it. Mathis believes they're tapping into an energy source that traditional physics just doesn't account for. This is all incredibly fascinating, but I have to admit, I'm still having trouble wrapping my head around it all. It just seems so radical, so different from everything we've been taught. I hear you. It's one thing to talk about spiders and comets, but to think that one single concept, this charge field, could explain so much about the universe, it's a big pill to swallow. It definitely challenges our assumptions. But isn't that what science is all about? Questioning, exploring, pushing the boundaries of what we think we know? True enough. And Miles Mathis, he's certainly a master at pushing those boundaries. But the big question is, where does it all lead? If this charge field is real, what does it mean for our understanding of, well, everything? What are the implications? And that's what we'll explore in our final part of this deep dive. Alright. So we spent this whole deep dive with Miles Mathis and his charge field theory. We've seen how he uses it to explain all sorts of things, the Earth's magnetic poles flipping, those weirdly active comets. But where does it all lead? What's the bigger picture here if you had to sum it up? I think the real heart of Mathis' work, it's not just the specific explanations he gives, but his whole way of thinking. He's like, hey, let's look for connections. Question what we think we know. Maybe there's a simpler, more elegant explanation for the universe than what we've come up with so far. It's like he's saying, instead of trying to make all these separate pieces fit, maybe we're missing the bigger picture. Exactly. And, even if some of his ideas don't pan out, just the act of questioning, it can lead to amazing discoveries, new avenues of research, fresh perspectives. Who knows what we might find? It's like that saying, if you always do what you've always done, you'll always get what you've always gotten. Mathis, he's definitely shaking things up. He is. Making us consider that maybe, just maybe, the universe is a lot more interconnected than we tend to think. Okay. So let's say, just for fun, that Mathis is onto something. Yeah. That this charge field, it's real. It's the foundation of everything. What changes? Well, for one thing, physics textbooks, they'd need a serious rewrite. Gravity, electromagnetism, all those fundamental forces, we might need to rethink them completely. Now you're talking about a massive shift in our understanding of, well, everything. No doubt about it. It'd be a revolution in science. Our understanding of everything from the smallest particles to those giant galaxies, it would all change. It's almost too much to wrap your head around, but that's the beauty of science, isn't it? It's always evolving, always pushing forward. Exactly. And who knows? Maybe someday, we'll look back and say that Miles Mathis, this independent researcher who dared to challenge everyone, he was the one who set us on the path to a whole new era of discovery. Well, this deep dive has definitely given me a lot to chew on. So to our listeners, we'll leave you with this. Don't be afraid to question, to explore, to consider those ideas that might seem a little out there, because sometimes the most unexpected paths lead to the most incredible discoveries. Thanks for joining us for this deep dive into the world of Miles Mathis and the charge field. Until next time, keep those minds open and keep exploring.